Hey guys, welcome back to my channel. So today we are going to learn about several topics like absolute and relative paths in Linux. Then we are going to discuss about the file permission in Linux, and then we are going to learn how we can do the read, write and execute operation on file in Linux. So let's begin. So to learn about absolute and relative path, let me start a terminal. So here first of all, the first point which comes is how is the Linux file system actually arranged. So Linux follows a hierarchical file system. So what does it mean? It means that everything is in a hierarchy, that is that every file is a child of another file, and in Linux we have a file structure like slash, that is the root, and that is called as root, and it's the parent of all files and directories. Then we have several folders like slash dev, then slash home, slash dev, then slash home, and so on. And then further we can have inside slash home we can have slash home, and then suppose my user is Linux geeks, so it will be a next. So if I say here, then I would say it's a parent of all, then is the first child, and then this is the second child. So if I show you the same here, then you can see then you can see that we have first we have cd slash, so this is pwd, then you can see this is the parent of all things. So if I do ls here, then you can see everything inside it, and it is the first child of slash. Then if I do pwd now you can see that I am inside the second child, that is the Linux geek of root, and home is the first child of slash. So this is how the Linux file system is arranged, and it is different from the Windows, because in Linux we don't have any partition defined as in Windows. In fact, we have a slash, that is the root file, root, and then we have the all the children's arranged below it, and they may be the direct predecessor or the indirect predecessor. What do I mean by that? It is same that it can be a first child, or it can be a second or third, or so on. Now we have understood the file system. Now we will understand what is the absolute and relative path in Linux. So suppose I am inside home Linux and I create a folder test here. Okay. Then I go back, and then I create one more folder with the name test1, and inside test1 I say I have created one file again, touch d. Then if I want to go to folder test, then there are two ways of going there. One is either I can do cd dot dot, that means first I will navigate to the parent. Sorry, let me show you this way. So if I want to go inside test1, that is one folder back, and then one folder back, and then again inside test. So this is where the test lies. So if suppose, let me go inside test1 again. So So if I want to go to test folder, then there are two ways. Either I can do cd dot dot, that is first I will navigate to one file folder back, then I will move to test, and here you can see now I am inside test folder. So if you want, or if you refer the file with the current location, then it is called as a relative path, because it is in relation to the current path where you are. And if I want to go to test one again, so there are again two ways. Either I can do dot dot slash test one, or I can give the exact path, that is home Linux geek and test one. So this is another way in which I have used the location from slash. So this is called as the absolute path in Linux. So I hope it made sense. So in case of absolute, we say we take slash as reference, and relative we take current directory as reference. So that is the important point which we should be aware about when we are talking about the paths in Linux. Now moving on further, let's move to file permission in Linux. So create one file. So I already have one file D here. I will remove it. Then I create one file here using my editor, and I will write here that's equal hello. So now if I do ls-l, you can see that the Linux geek is the user of it, and Linux geek is the group of it. So okay, so let me discuss one by one. So first character defines that it's a file. So if it was a directory, then it would have been a D character here, but since it is a file, it will be a slash. Now the first three characters, the first three character after the first character, the next three characters represents the permission. Okay, let me write it here. So it is something like first character is slash, then R, W, and dash. So R here, the first R, here represents the read permission for user, and in this case our user is Linux geek. Then the second character says that write permission for user, again Linux geek in our case. And the third permission says execute, so execute permission. So let me write it in short. And here you can see that Linux geek cannot execute because the permission says no execute permission. So if I go, and as of now let me tell you the way how we execute file in Linux, and that is /test/, and you can see it is saying that permission denied. So what can I do for it to make it executable? So what I will do is I want that user should have execute permission, and the file is test.sh. So if now I execute it, you can see it has successfully executed the commands inside test.sh. And if I show you the content again, then it was echo hello, which has been executed successfully. And if I show you the permission again, when I did chmod u+x, it has changed the user permission to execute. It has added execute permission for user, that is Linux geek. So these first 3 bit represents a permission which is allowed for the user of this file, and this field represents which user or who is the user or the owner of this file. So let me write it here. So first 3 bit represents the user or owner of file. File represents permission for the first 3 bit, or we can say characters, represents permission for the user or owner of the file. Now the next three characters, that is -rwx, then again in our case it is rw. So rw and then hyphen. Okay, we paste it here. Let me copy paste it here. Give me a second. Copy and then paste it here. Okay, there is some problem with this editor. So okay, I will just highlight it here. So leaving the first 4 characters, the next 3 characters, that is this one, represents the permission which are assigned to the group of this file, and in this case this field represents who is the group owner of this file. So you can see again here Linux geek is the group owner of this file. What does it mean? It means that if we look at our group file, and in that if I grab for Linux geeks, so you can see Linux geek is a group in which again I need to do pass wt, and I will do grep Linux geeks. So you can see that Linux geek is a user whose UID is 1001 and whose GID is 1001. So here Linux geek is a group whose ID is Linux geek is a group whose ID is 1001, and the only member which is a group of this, or which is a member of this group, is Linux geek whose UID is 1001. So if I go by this definition, it means that again Linux geek has a read write and no execute permission on this file. So but since read write execute are already provided to this file, this user, the Linux geek, on test.sh, so this will take priority, or we can say this will override these permissions, and the Linux geek has all the permission on this file. And now the third field is the next 3 fields represents the permission for any other user apart from this user, that is Linux geek, and the group Linux geek. All the other users will have only the read permission and no write permission. So to test this, what I will do is I will just create one more user, add user test. Sorry, let me add one more user test, and then I would say password for it is something like so what I have done is I have just added one more user, and that was user test here. And what I will do is I will go to this user, and inside home Linux Geek I will go to my folder where I have just created that file that was inside cp test1, and now I will try to execute this. So you can see it is saying permission denied. Why? Because right now who am I am user test, and this permission says that any other user who is not Linux Geek, or he is not a member of Linux Geek group, will not be able to write or execute this permission. So if I try to write also, it will not allow me to write. So I have opened the file in text editor, and when I try to change this file, it will say warning, changing a read-only file. So it will not allow me to change this file. So see, it is saying read-only option is set, add / to override, and even if I try to override, it will not allow me to override this file. So this is how the permission in Linux are defined. And apart from this, we have already discussed on this one. This is the user or the owner of this file. Then this represents the group members who are the owner of this owners of this file, and this represents the size of this file. So to represent or to check the size, let me do this. So what I have done is I have done word count wc does not have any exact wc does not have any exact full form. So wc basically is used to count the number of lines or characters, or it can also count the number of lines and characters and words as well. So right now what I have done is I have just mentioned the option C, which will count the characters for me, and you can see that there are 26 characters in this. So the size of the file is 26, and this is in bytes. So 26 bytes is the size of the file, because there are 26 characters exactly in this file, and this represents the creation time. This represents the creation time, and this represents the date on which it was created. So it was on 15th of Jan on which it was created. There is one more particular information that is represented in this ls output, but for that we will have to use -i, and that is the inode information of this file. And this is a very important, or we can say this is a very important topic and a part of a file. We will discuss on this on another lecture, when we will discuss about soft link and hard link in Linux. So I hope this much is clear. What are the permissions in the file and how we can do the now we will move further, that how we can perform the read, write and execute permission on a file. So for reading we have several commands in Linux. So as of now we have seen cat. Now moving on further to the another command, that is more. This can also be used to view a file, and it is generally used when the size of file is more than the size of the screen, or you can say the file is not able to fit in one screen, so we can use more to view the content of the file so that it is more readable. And to have an example of it, let me first go to the definition. File per visual filter for CRT viewing. More is a filter for paging through text one screen full at a time, and this version, so it is basically displaying the whole content one screen full, means in one screen at a time. And to do this, what I will do is, let me check one file. So what I will do is, I will do test.sh, and I will, okay, I'm logged in with user test, so I will move back to Linux keys, and then I will move inside test one, and then I will change the content of this file. So let me delete this, then I will paste it again. Give me a second, I will see how can I so let me create a random file with so many lines there. So now I have enough lines, so if I do wc-i, you can see there are 72 lines in this file. And now if I want to view the content of this file, when I do test.sh, you can see half of the content is gone, and if you scroll your cursor above, you will have to read it in this way. So to overcome this, what we can do is, we can just use more command, and then then the name of this file, and that is test.sh. So now you can see that it is saying that it has displayed 56% of the file. And now if you want to view the further content of this file, you can press space bar and it will show you the next page of this file. So this is how you can make use of more command. And to quit, you can press escape here. So we have seen cat, we have seen more. Now suppose there was a big file and you want to okay, let me discuss less first. Less is also the same as more, and let me check the content of less, opposite of more. So less is a program similar to more, but it has many more features. Less does not have to read the entire input file before starting, so with a large input of faster than the textual live vi. So it is similar to more, and you can read further on it because I don't use it much. So moving on further, and it is similar, and okay, so less is much similar to more. So I think if you know about more, then you can use any one of it as per your choice, and you can read about it. And going on further, we have a tail command and then head command. So tail basically is used to view the content of the file starting from the bottom. So what do I mean by this? So let's suppose I have a file test.sh, and you can see that if I want to view only the last 10 lines of this file, then what I will do is I will say tail n, and see we have 10 empty lines here, so it did not show us any content. So let me delete the empty lines first so that it will be clear. And in the last line I will write last line, so that it will be much clear. And in the first line I will say, or it is artificial, so this is my first line. So when I do tail, it will, so when I do tail hyphen and 10 test.sh, then it will show me 10 lines along with the last line. Sorry, it will show me last 10 lines counting from the end of the file. So you can see the end of the file is this, and here we have total of 10 lines displayed. So if I count it manually, this is line number 1, 2, 4, 5, 6, 7, 8, 10. So you can see that from the end of the file it has given me 10 lines. Now if I want to do opposite operation of this, then we have that command, and which is used to display, or which will display the lines from beginning of the file. So now you can see from the beginning of the file it has displayed me 10 lines. Again, if I count the lines in my output, it is equals to 10. So you can see that how we can use head and tail to read a file, and read a file selectively. So if I go here, then I can say that tail and head used to view file selectively. Now this was the basic uses of head and tail, but in industries, how we can make use of this command. So let me give you an example which will show you how it is used in industries. So let me this line is to be picked. So I will say test so I want to get this line number 21, and I want to make use of tail and head here. So what I will do is, how can I do that using my head and tail command if I don't know the use of grep? So basically what I have to do is, it is saying that this is line number 21. So what I will do is, I will do head hyphen and 21, then test.sh, and then I have tail hyphen and 1. So see how it has what you can say, pick that file for you from this file test.sh. So this is how it is used in industries, and this is a very much useful command which will help you to get the contents or extract the useful content from your output whenever you are using it. Let me give you one more example. Suppose you have a host file in your system, don't go by the content, and you want me to print the last 2 lines of it. And what I will do is, I will just do tail hyphen and 2. Now other way, you want me to print the last 3 lines, or we can last 3, or sorry, or you want me to print only the highlighted lines here. So what I will do is, you can count it from here. So these are basically 4 lines, and then you don't want the last line. So how you can do that filtering here? Then you will use cat etc tail hyphen n. Then you want me to print first 4 lines. Now you don't want the last one, so you can do head hyphen n 3. So see Now you have excluded this last line from the output, and you have printed these 3 lines in your and you have got these 3 lines in your output successfully. So this is how you can do filtering with tail and head in Linux. So I think we are much clear about these commands now. Let's move to the write command. So in write command we have already seen touch. Touch is basically used to create an empty file, and let me have an example as well, though we have seen it earlier. And then to check the content of the file, we have already seen the cat command. So if I do cat of t, then you can see that touch has created a file t which has no content inside it. Now then we have editor based, so that also we have seen. Let me show you this again. So test.sh. So now if I do cat t, then you can see that tst.sh has been saved in the file t, and this time we have wrote the content inside t using vi editor, and instead of vi editor you can use any other editor. So we have written to write a file we can write a file using any editor. So this is the second method in which you can write a file. And the third thing is redirection. So what does it mean? So let me give you an example, but before doing that, let's discuss one more point. What if I do I have a file t, and what if I want to create a new file? Okay, so sorry, that was not the case here. I will move further. So the third thing is we have echo. Okay, so in echo, if you want to write in file using echo, then you can do it in this way. So now if you will check the content of t, it has changed to hello. So this is called the redirection. This is called as the redirection, and this is also the way in which you can store or write a content into a file. And the other way of doing this using redirection is echo hello. Now if I see the content of t, in the previous example, if you would have noticed that hello was overwriting the previous content of t, that was tst.sh. so it got overwrote by this hello, but in this case it has not overwritten the content of t, and it has just appended it. So I think you would have got the difference. In this case it will overwrite the content, and in this it will append the content to your file instead of overwriting it. So here for redirection we have either this or double dash. This is used when we want to overwrite our content and this is used when we want to append our content. So I think we are clear on how to write any file in Linux. Now we will move further and we will see how we can execute a file. So till now we have seen the source, and source is basically the dot which we have used, and this is how. Okay, so let me check the content of test sh first. Okay, so there was some characters which were not Linux commands in test.sh, so let me empty this file. And for emptying the file, we can simply do echo, and we will overwrite the file test.sh with nothing. So if I see the content of this, it is all empty. Now what I will do is I will write echo hello, and now I have the execute permission. And who am I? I'm Linux Geek, so I can execute it. So this is the first way in which we can execute the file, and this is similar to source test.sh. Now the second way in which we can execute this same file is using sh test.sh, and the third way we can do is exec test.sh. Okay, so this is not the way. Okay, pardon me for this one. So we have seen two ways in which we can execute a file, that is source. What it will do is it will run inside the current shell, and the changes is attribute environment. What does it mean is whenever we execute this test.sh test one use keys, and then test one, and now what I will do is I will execute it using test.sh. So when it will execute this test.sh, it will do it in the current shell itself, and if I do it or execute it using sh.test.sh, what it will do is first it will start a new shell, and inside that shell it will run this test.sh. So basically the difference is that it will not, in the first case it will not fork a subshell, and in the second case it will fork a subshell, and any change which is done to the attribute or the environment is not transferred back to the parent shell. So I hope this made sense, or I can say here, suppose process 1 will first execute, or process 1 will execute command in the same shell, but in this case process 1 will fork new subshell, and then inside that process 2 is executed, and once this is done, then return status is return to process 1 in the same cell, and in this case also it will return the status process 1, then process 2 execute command in the same cell, and then finally it will return the status to process 1. So I hope this is now clear. So that is all for this lecture. We will learn about hard links and soft links in our next lecture. So till then, goodbye. Thank you.